we're all here, right? So what is programming? Um, Programming, it sounds very intimidating to, especially when you're first starting off. But really, programming in essence is, I like to think of it as almost an art form. And with any kind of pieces of art, the goal here is to just create, right? Like, what are you creating? You could be creating something visual, you could be creating information. And so fundamentally, what programming does is, you put in some information and you get out other pieces of information. And so the goal is for us to actually use the program or the power of the computer to really do something, transform that input in some way. This could be simple as us writing code and getting back images, right? Or it could be me saying, let me give you two numbers and I want you to add them up for me and give me back the answer. Programming is, despite it being art, it is also very logical and has a lot of decision making aspects to it. One of the things I'd like to say a lot is that computers are great, or rather programming language, which power computers, they're great at doing very clear, very logical steps or calculations a million times or a trillion times faster than a human and more accurate than a human ever could, right? What they're bad at is ambiguity. And what that means is that whenever you're working on any piece of code or any piece of kind of program, always know that it helps one to put yourself in the shoes of the computer and think about how you would execute on these tasks if you were the computer. But more importantly, also know that when you're talking with someone, when you're working with a coworker, you might be able to afford to be ambiguous, right? Someone may say, "Hey, how do I do this?" And you might say, "Oh, just Google it," right? Even in something as simple as that, when we say it to each other, there's a ton of connotation there that we know, that we think that the person knows what we're talking about, right? It means log into a computer, open up your browser, go to google.com and type in whatever it is you're searching for, right? Computers, on the other hand, are horrible at ambiguity. They need to be told exactly what to do, and they will follow your exact instructions down to a T. And if you give it improper or incomplete or not the right directions, then your program's not going to work. So whenever you're looking so whenever you're working with code, always remember, right? The computer can never guess or kind of figure out what you want. You need to always be as clear as possible about what you want at all times. And so that's kind of where the high level rationality and analysis piece comes in. Programming is very repetitive, both in doing it kind of as a full career, but also when you're learning, especially. It's kind of like shooting a basketball, right? Everyone kind of theoretically knows how to shoot a basketball, but unless you do it 1,000 or 10,000 or a million times over, you're just not going to get better at it. It's the same thing with programming. Just because you know how something works, it's very different than being able to actually put it into practice. And last but not least, there's this kind of stigma against programmers as being people who are locked in a room by themselves in a dark room, usually overly caffeinated, kind of hacking away to all hours of the night. When in reality, programming is actually a very social activity. Almost anything that is extremely worthwhile that's been built in this world, especially in the realm of computer science, has been done so by teams. Now, you may have people who are very smart who are leading that charge, but if we take something like Facebook, right? Like no individual human being could not just build Facebook. No human being can build a feature of Facebook by him or herself, right? It takes a team. It takes a lot of collaboration. It takes a lot of brainstorming to build. And so one of the things we also want to work on throughout this cohort is not just to say, hey, do you as an individual kind of know or memorize the technical details? But really, it's just are you able to collaborate and talk through some complex problem-solving issues with another human being? Yeah. So throughout this, actually, one more thing is on the last bullet in terms of this being a creative process. One of the common things I always get asked is, am I doing this right, or is this the right answer? And with programming, there's very rarely a single right answer. There's obviously answers that don't work, that don't give you the outcome, and there's probably better answers and worse answers. But even in that vein, there's always going to be you can always have multiple answers that do the same thing with about the same efficiency, and one is not better than the other, right? It's more about figuring out how you want to solve this problem and being able to articulate it. As we go through this cohort, one of the most common questions I'll ask you, especially if you're stuck on something, is just, okay, walk me through what you've done so far, right? Like, are you able to clearly and logically articulate to me what you're doing and how all of that process is coming along? And if you can't, then it means, okay, you have this huge gap in your knowledge, right? Where you know, um, a way to think about it is almost like if you want to build a house, you kind of need to plan beforehand where the bedrooms, the walls, the bathrooms are, right? When you write code and you don't quite know what you're doing or you can't explain it, in my mind, it's almost like you're trying to build a house and then you start just putting up planks and nailing things to walls and boards to each other and praying to God that eventually at the end of it, it'll become a house, right? Like, so, it's creative in the sense that there's a lot of flexibility, but you need to combine that with a logicalness, which is that you need to actually be very clear about what you're doing at all times. In this cohort, we'll be talking about three languages, or we'll like to say three aspects of programming. And they're actually the things that probably all combine to create most of the basic web pages that you see nowadays. So we want to keep this very relevant to you. They're HTML, they're CSS, and they're JavaScript or JS for short. What's the difference between them? HTML stands for this thing that you will never need to know ever again, so not a big deal. Basically, HTML is going to be what we like to think of. It's analogous to if we're trying to say a website is a human being, then HTML is going to be the skeleton of the website. It tells you where each physical component is, and it also is a way for it's a way for your browser. So if you're using Chrome or Firefox or Safari, or unfortunately if you're still using Internet Explorer, it's a way for your browser to actually know how to render or show the code that it's getting, right? When you go to Facebook.com, right, or when you go to CN.com, right, CN is not giving you like an image or rather, they're not giving back to your browser an image of CN.com. What they're actually giving you is a bunch of code that then that your browser then translates into the visual of CN that you see on your browser. And so HTML is the raw language. And once again, it's very important for us to get it correct, because if you give the browser the wrong HTML, the browser is not going to know that HTML is incorrect. It'll just say, let me try transferring it into or rendering it into a website or an image, and we'll try using that regardless. CSS, on the other hand, then, so whereas the HTML becomes like the raw skeleton, it's the raw components of your website, the CSS is like the skin, right? It's the things that make it pretty. So we think about colors, fonts, background, formatting, shapes, alignment. CSS is a tool, a language that we use to help us kind of basically make websites a lot prettier. The last thing we'll talk about is JavaScript, and this is kind of like the brain or the nervous system of the web page. JavaScript is what allows your web page to be able to do cool things, right? So if I hover over a button and it turns green, I want to be able to handle that. If I'm having you complete a survey on my website, JavaScript helps me handle that. If I want to submit a form to somebody, or if I want to fetch a piece of information, JavaScript helps me handle that. And so JavaScript really does become kind of like the more, I should say, it's not just computational, but computation is definitely a part of it. It becomes like the actionable part of the website, right? It handles all of the logic and the action steps on the website. So once again, today we'll be starting off by talking about HTML, so the bare bones component. Tomorrow we'll talk about CSS, so the skins and kind of the things that make a website pretty. And then the 3 days after that, we'll be talking about JavaScript. So how do we kind of handle more complex actions and commands when we're building a website? So, yep, made a slide for this. Skeleton, skin, and then the brain or the nervous system. Okay, any questions so far before we dive into the HTML section? Yep. Yep. Yeah, so we're still working. I'm still working with the staff. I'm trying to figure out where we're gonna upload these. And if we do choose to, I'll let you guys know. Usually, if we do upload them, I'll be sure to send out a link to them, so you have access to them like post class. Yep. Yep. Any other questions? Everyone's good? Everyone makes sense, everyone? All right, great. So let's dive into HTML then. Okay. So, like I said, the intro to HTML is once again. Oh, sorry, there's a question now here. I think someone chatted to me. Um, okay, great. Um, yeah, one thing about the chat is that, and this is kind of a limitation of the Zoom platform, is that when I'm in presentation mode, I actually can't see the chats come through. And so if you do have anything pressing, whether it be a question or anything like that, feel free to just unmute yourself and shout it out. If you chat it, I literally may not see it until the end of the presentation sometimes. So apologies on that. Also, it helps me make sure that people are kind of still here and I haven't put them to sleep yet if people are asking questions throughout. So that makes me happy too. Okay, cool. Okay. So, like I said, HTML is the skeleton of the web page, right? It's kind of how it's the language that we use to create the bare bones or the components of the web page. When you write HTML, you make a lot of the same decisions about the text that you make when you use a word processor like Microsoft Word or Google Docs, right? You type out your words and you structure your documents. You decide where the headers are, you decide where the paragraph indentations are, you discuss if there's white space, etc. You decide if you want to add an image or other text features, or text features, or image features for that matter. With HTML, with Word, usually we do that through a graphical interface, right? Like if I want to create a space here, I go into Word and I hit the Enter key, and in the Word UI, you'll see it actually creating a space in between two lines of text, right? With HTML, rather than doing it through text, we do it through code, and so what that means is we use a special we use a special syntax to tell a browser what we want. And if we want a space between two lines of text, then we need to actually insert a space component between those lines of text, so that when a browser reads the web page, it says, "Oh, great! This person wants me to show a line of text here, show a blank line here, and then show another line of text after that." So in this section, we'll learn how to not just write HTML, but also how you're able to see the results of your HTML code going forward. The skeleton. Okay, cool. Yeah, so we'll see the results of your HTML code, how we write the elements. So those are like the components or the pieces of your website. We're going to go over some very, very basic components, and this is a list of the most commonly used components. It's by no means an exhaustive list. I don't know if hundreds is an exaggeration, but there's a lot of different components in HTML. And then we'll also talk about how we can customize extra information to these components or these pieces, and then how we can use to create things that are more graphical, like links or images. Okay. So on the left-hand side of the page, you're going to see, which is essentially a website that you and I may visit at any point, right? Notice how the text, I'll placeholder text, so no need to read the actual text itself, but just notice how there's a big block for the header, then a small paragraph text, and then there's another header, another paragraph text, and finally we have two cute images on the bottom, right? So this is the kind of image that you're used to seeing when you go to a web page. However, what's actually being communicated to your browser, or what's actually being sent to your computer, looks something more like what we see on the right-hand side, right? It's a lot of text for sure. In fact, there's no images. And more importantly, once again, someone could read it right away, and you might be able to match, some of the text from the left-hand side to the right-hand side. But for the most part, like all the components are there, but for the most part, it looks a little bit different, right? And the reason why is because this is HTML, right? This is kind of how we diagram out the components of your web page. It's the same reason why a house looks different than a blueprint, right? If you look at a blueprint, you have no idea what you're looking at. But then when someone builds a house, you're like, oh yeah, that looks like a very nice house. So everything in HTML is essentially built using something we call elements, right? They're the building blocks of HTML. An element in HTML typically consists of a pair of tags. So you have an opening tag and a closing tag. What do I mean by tags? If you look on the very first line there on the right hand side, you'll see that's a body tag. And how do I know it's a tag? Is because it starts with I guess we'll call that less than caret, and it ends with a greater than caret. And so the carets are basically what tells the HTML language, hey, this is going to be a tag. And we know whether or not something is the beginning of a tag or an end of a tag because if we look at the beginning if we look at this tag, all we have is a less than caret, the word body, and a closing caret, right? This is the opening caret of a, this is the opening tag of a body tag. If we go to the very last line on the right hand side, you'll see the closing tag of a body tag, right? We have the less than caret still, and we still have the body plus followed by greater than caret. But now in front of body, we have this backslash or forward slash, however you want to call it. That slash essentially tells us, hey, this is a closing part of a tag, not the opening tag. And so between the first body tag and the last body tag, it actually encapsulates the entire website, which makes sense because if I think about a body of a website, well, that's pretty much all the visual things I'm going to see. And that pattern isn't just maintained in the body, right? If you look on line 2 on the right hand side, we have our h1 tag, right? On the first 4 characters there, it's a caret followed by h1 followed by closing caret. We know that that's an h1 tag because the line in between it says h1. And we know it's the opening h1 tag because if we look at the end of line 2, you'll notice we see our closing h1 tag. How do we know it's a closing h1 tag? Because in front of h1, we have that backslash again that tells us, hey, this is closing. So this draws to a pretty important, or 2 important ideas, right? One is that every tag in JavaScript, every tag in HTML, for the most part, we'll talk about some exceptions later on, but most of the tags have an opening tag and a closing tag, and all of the information that you want to belong to that tag goes in between, right? So on line 2, the h1 is a great example. I have my opening h1 tag, and then I have my closing h1 tag, and in between I have the text. That's basically my header. Okay, h1 in this case, we'll talk about what h1 is more detail in a little bit. But h1, as you can tell, is h stands for header. It just means, hey, take all of that text and put it in the header. If we move down one more step on line 3 there, notice how we have what we call a p tag, right? Pretty straightforward. It's an opening caret. It's a pair of carets. In between it, we have just a letter p. Beneath it, we have a bunch of text, and we know that that's going to end at some point because on line 5, right after the text, we see our closing p tag, right? And once again, it's closing because it's still a p tag, but it has a backslash, or I'll just call it backslash for now. It has a backslash in front of it. So this is holding to our idea of each tag has an opening tag and a closing tag. That's the first idea. The second idea then becomes that the closing tag is going to close the closest by proximity tag, right? It's basically it's going to close according to the closest opening tag that comes before. So let me just. It sounds really complicated when I say it that way. Let's take a look at the image and hopefully become a lot more clear. I actually exit out of presentation mode for this, so we can just zoom in on this just a bit more. Okay, and then we don't need this, and then we don't need how do I close this out? Sorry, I'm just trying to show this so we can even make it a little bit easier for you guys. Okay, whatever. Okay, so here, this is a p tag, right? P stands for paragraph. It's what we use to show plain text. So here is a p tag. Here we have an h2 tag, and here we have another p tag. Okay, so the first idea is that wherever I see an opening p tag, I must see a closing p tag somewhere else on the page. Similarly, if I see a closing p tag, then I know there's an opening p tag somewhere else on the page. The second rule is that the closing p tag, in this case the closing p tag, this is going to quote unquote close the closest opening p tag that comes before it. Why is that important for us to know? It's because of that rule, I know that this p tag corresponds to this p tag. This p tag corresponds to this p tag, right? This p tag does not correspond to this p tag because there's another opening p tag that comes closer right before it. Does that make sense? So whenever we're looking at a block of code, it's super important for us to know when we're looking at a block of code, kind of where the block starts and also where the block ends. And so in HTML at least, we know where something starts and where something ends is because whenever we see an opening tag, we know it ends where the closest closing tag that comes after it is. So when I see this opening p tag, I know that whatever text comes next, this is going to be what comes after it. And this applies to everything on this page, right? This is a body tag. How do I know that this is a corresponding closing body tag to it? Is because there's no other open body tags in between this opening tag and this closing tag. Okay. And so I know I'm kind of talking a lot right now in terms of the tags, but this is pretty much like the bare basics of HTML. If this makes sense to you, then hopefully the rest of this should be coming a lot easier, right? Tags or elements are the basic components of a HTML element. Elements are usually comprised of pairs of tags. You have an open tag and a closing tag, and all the text goes in between, and then the closing tag closes the element, the opening tag that's closest to it. Any questions? Yep. Go ahead. Yep. Yep. It's a great question, and I'll cover it later in the presentation. But the short answer is yes. Every single thing from the white spaces to the margin, everything is defined somewhere. It's just a lot of times we don't see it because Java or because HTML, honestly, it tries to help us out by making some decisions for us. Yep. Yep. Cool. Okay. So if we just now kind of do a in-depth dive of what we just talked about here, right? We go back to this idea of elements. So the p tag in line 1, once again, that's kind of the p stands for paragraph. It's what we use to usually show plain text. H tags, on the other hand, goes from H1 all the way up to all the way down to H6. H1, so H stands for header, and basically whatever text you put in between the header tags just get bigger, right? And so that's what we're trying to show you on the right hand side. Whereas the P text might be smaller, the H tags make the text bigger, and the bigger the number, the smaller the header. So H1 is the biggest header, H2 is the next biggest header, all the way down to H6, which is a very small header. And then if you want to go any smaller than that, you might as well just do a P tag or a plain text. One thing that we're also going to see that's a little bit confusing is some tags like image tags, for example. It doesn't have a quote unquote pair of tags. There's no open tag and a closing tag, and the reason why is because with an image, the idea is if I have an image element, right? Like nothing's going to go in between it, right? I can't have a picture of a dog and have something in between it. It's just a picture of a dog. And so because of that, there's no open and closing tag. It's what we call a self-closing tag. And so if you look at the third example there, we have our opening caret, we have our img, and then we have some attributes we'll talk about in a little bit. But notice how the tag ends with a backslash followed by a close caret. That's what we call a self-closing tag. And so what that means is that's a full image tag. It's both the opening and the closing tag kind of are combined into one unit. There's no pair tags, it's just a single tag. And we'll talk a little bit about what that text in the middle means when we talk about attributes and references. Cool. So now that we know kind of now that we've kind of talked a little bit about how the basic elements look, right? Is that, oh, like I have a website. This means I have some random hodgepodge of text, whether it be paragraphs or headers and images. Now let's talk about how we actually want to arrange these elements going forward. And so one of the ways, so there are ways in which we can arrange the elements by ourselves. So we can say, I want a paragraph here, and a paragraph here. But HTML also gives us some built-in tools that make it a lot easier for us to arrange elements by order as well. One of whom is the UL tag. And so what the UL stands for is unordered list, right? And so if I was to see this in the wild, it would still look like a caret, UL, close caret, right? And beneath it, and then within that, what we have are going to be elements that are going to be what we call list elements. And this brings us to kind of this important concept we have when it comes to arranging elements in HTML. We call it the parent-child relationship, right? And indeed, we've already seen an example of a parent-child relationship already before, right? Remember how when we had our body tag, it was like body tag open, body tag closed, and in between there was like 4 or 5 different other elements. Well, when we have things that show up in between the open and closed tags of an element, then what we say is that that container element, that's the parent element, and the child element are the elements that are inside of the parent element, or that they belong to the parent element. Unordered list in JavaScript is a way for us to model that behavior, because an unordered list tag shows up at a very high level, and then in it, it's going to contain as many list items as you want, right? And so whereas the unordered list becomes a parent, then each individual list item subsequently becomes the child element. And if we kind of take the family analogy one step further, then the child becomes siblings of each other. And so if I take a look at how this looks in practice now, I now have this snippet of HTML. We have our body tag on line 1 and the very last line, so I know everything in between it is our children of the body tag. Then we have an h1 element, so a big header that says list, and then in it I have an unordered list tag right in the beginning of line 3 there, and then after that I have a bunch of list elements. I have li, and then I put whatever text I want to be in between the list elements, and then I have my closing list element tag. Notice how, once again, right, I know which opening list tag matches to which closing list tag, because the opening one, then the first closing one after the first opening is going to match to that one, and so on and so forth. And then on line 6 there, notice how I have my closing unordered list tag there. And so when I render this out in the real world, or rather when I graph this out in code format, what we see is here I have my initial body tag, and then after the body tag I have 2 child elements in there, one of whom is the h1 tag, and in it I have this word called list, and then I have my other unordered list, and then that has 2 more quote-unquote child elements, one of whom is one list element which has text 1, and then another one which has another list element which has the text 2. And so this is what we mean when we say that for a lot of HTML web pages, you can actually draw it as almost kind of like a graph. Say like, hey, I have this one thing that then gives like 3 more or 2 or 3 more things, and that has more child elements and the more child elements. And so we almost graph a web page in a lot of ways in the same way that we graph a family tree. Everyone so willing so far? Okay. Oh, sorry. Good. Awesome. Okay. So, did I? Okay. Yep. Sorry. This is covered. Okay. So as you can tell, like the relationships between elements are actually very important, right? So we know like where, like who belongs to what, and it's because, and so one of the ways that has emerged as a primary way for us to show that family relationship, not just in HTML but also in CSS, JavaScript, and I think in almost every computer language, we like to use the concept of indentation to show when something's a parent and when something's a child, as in the child elements are usually indented 1 unit relative to the parent. When I say unit, that's just a way of saying it could be a tab, it could be multiple spaces. People have very strong opinions on this. Honestly, in my opinion, it doesn't matter too much. The most important thing is that you're consistent when you do it. And so here, if I look at the HTML snippet on the left, you'll see I have my div, and div is another new tag. And it's actually probably the most common one. A div is just a way for us to say a container. It could contain text, it could contain images, it could contain anything. It's just a container. Beneath it, we have the h3 tag, so it's a medium-sized header tag. And then beneath it, I have 2 lines of text, which I put under the p tag, right? If I look at the left-hand side there, it's not really clear to me which one is a parent and which one is a child. But if I look on the right-hand side, now because the div, now I see the h3 and the 2 p tags are all indented relative to the div tag. Now when I look at it, like visually, just kind of really quickly at one glance, it tells me, oh, the div tag is the parent, and it has 3 child elements, 1 h3 element, and then 2 paragraph elements. right? So this becomes so not only do we have these relationships in HTML now, it also becomes pretty important for us to be able to show it in a very readable, kind of easy to understand manner. Yeah, so that's a great question. Body, typically speaking, is only used once on a web page, and it's to separate the body from the header. The header on most web pages is kind of where you fetch external information. So if I go to, for example, my Facebook page, um, the header is going to be where they get my credentials, my passwords, my user information, all that stuff. And then the body becomes how you actually show that information. So usually speaking, body is only used once. Div is used literally thousands, if not millions of times on a web page. After this, I can show you guys a common web page to see how it looks, but you'll see divs is probably by far the most commonly used element. Whereas body, your web page will only have one body, right? Which kind of, yeah, as the name indicates it. Yep, yep. And so yeah, so the left hand side is an example of code that runs, but is considered poor code. On the right hand side, it's better code because of the indentation. Um, this also brings us to the next topic of something called block elements versus inline elements. And so if you're just kind of keeping track, right, we started by talking about the elements, which allows you to maybe have a line of text here or a header here or a picture there. Okay. And then we started talking about this idea of parent-child relationship, which is to say that like, oh hey, like this element is actually a part of this element, right? Like, I want to make a list, so this whole thing is a list, and then here are my headers as well as the list items, and the elements start having relationships to each other. Um, but what block and inline elements talk about now, it's still talking about the relationship between elements to each other, but now it's more of a spatial relationship. So how do I look visually on the page? And the best way for me to show that is to give you some examples. So here on the left hand side, we have our two p tags that I've put on the same line. But once again, I know which closing p tag corresponds to which opening p tag because they're the two closest ones. So it looks like here I have two p tags with the word hello. And if I was to show them on a web page, even though I've put these two p tags side by side, on a web page, when I look at a p tag, it puts hello on one line, and then it goes to the next line, and it shows up the next p tag, which also says hello. Okay, and so this brings us up to like brings us to the first concept about p tags, which is that they're what we call block elements. What does that mean? It means each element, so each p tag or each p element, paragraph element, is its own block. It takes up the entire width of the web page, or at least one line's worth of the web page. Now, if I have so much text in there that it goes through two lines, then this block element will take up two lines of height, but it will still take up the entire screen in terms of width, right? And that's what I see here. It's clear, it's really easy for me to fit those two hello texts on the same line. But because I put those hello text inside of a p tag, what that's telling what that's telling HTML is saying, okay, render hello on one line and take up all the space available in that line. That's a blue border that you see. And then on the next element is another paragraph element, another p element with a hello text. Let's render hello on that line and have that element take up the entire width of the web page. If we want to contrast that, we can actually contrast that to something called a span tag, right? So a span is actually very, very similar to a p tag or even a div for that matter. The biggest difference between a span and a div is that spans are what we call inline element. What does inline mean? Inline means I'm going to use up only the space that I need on that line. Now, if I happen to need more space I don't fit on this line, then I will go to a new line. But in the previous example, when we looked at our p tags, notice how for even a small word like hello, it took up the entire line by default. What a span will do, which we see in these purple boxes. By the way, the hopefully I should have said this earlier. Hopefully it's clear. The color boundaries are just for your example, is for illustrative purposes. They're not there on the real page. Here, when I try to render the span tag hello, it says great. I only need half of this line to say hello. So that's all the space I'm gonna take. The next element says is a span tag, and that's going to say goodbye. And it does the same thing. It says, hey, I only need half of a line to say goodbye, so I'm just going to use the half of the line that's left over. And so one of the things that hopefully is that's a contrast. Sorry, I just finished this thought and I'll take a question somewhere. One of the things that you also notice here is that on the left hand side in the HTML portion, notice how I put the span, the two different span tags on separate lines, but when they render on the right hand side, they render on the same line, so to speak. If I go back to the previous example, here I put the two p tags on the same line in my HTML, but the way HTML renders it is on separate lines. And so this brings up another important thing for us to know, which is that with HTML, it actually doesn't matter how much spacing I put in between the elements. Then this might go back to, I think, Trudy's question from earlier a little bit. I'll talk more about white space in general. But when Chrome renders your web page or it decides how to space out your web page, it doesn't do so based on how you've spaced out your HTML. They do so based on how the elements that you've created, how they are designed to show up or show up. Oh, Summer, do you mind just turning down your speaker for 1 second here? Sorry, I think I hear some music coming through. Yeah. So once again, right, when we talk about HTML spacing, the arrangement and the elements on the page, it's not because of how you space your HTML code. It's based on the inherent properties that are existing inside those HTML elements. And so I could put two p tags on the same line here. I could put those two p tags on the same line, on separate lines, on different lines with 20 lines of white space in between. It's all going to render the same exact way, right? And same for the span tag as well. Sorry, were there questions? Let me just check the chats, and then Summer, I think you had a question as well, right? Summer, did you have a question still? Okay. If you're talking right now, I can't hear you. You might be unmuted, but if you have a question, feel free to just jump in. Okay. So this is just trying to give us a few examples of how span tags, or rather how block tags and inline tags look different, right? Header tags, as you can imagine, they're block tags. They take up the entire width of the screen, no matter how big the text is, no matter how much space the text needs, right? On the other hand, span tags are inline tags, so they try to fit in whatever space is available. And if I had 3 more span tags in there, then yeah, eventually it would go to the next line down on the page if I've taken up the entire width of that line on the page. But by default, it says I will only take as much space as I need. Is this somewhat C++ programming? No. I guess, why do you ask? Like, or what part of this reminds you of C++? Hello? Feel free to just shout out Summer. C++ is more of sorry, the reason why I say no is because C++ is more of a computational language. So there's a lot of similarities, for example, between C++ and JavaScript. In fact, JavaScript is in some ways just an abstraction of the C language. HTML is more of a kind of like a web design visual language, and so they don't necessarily work in the very similar way. Yeah, I mean, if you have any examples of C++ code, I'm happy to take a look at it. Like, you'll see a ton of similarities between C++ and JavaScript for sure. I can guarantee you that. With HTML, because they're doing kind of different things, you might see code similarities, but the functions are probably not the same. Can you use multiple H2s and H3s, or can you only use 6 headers? You can use as many of any tags as you want. And that applies even for the body tag. I know I told Andrew earlier that you only have one on a page. there's nothing that's going to stop you from having multiple. Other than that, it's bad practice. But generally speaking, you can have as many tags of anything as you want on a page. Cool. Yep. So let's wait for these animations to play out. Okay, the last thing we're going to talk about today is attributes. So attributes are so ID and class. Yeah, so attributes are basically extra pieces of information that we want to add to a given tag. Okay, so on the other hand here, on the left hand side in HTML, notice how I have a p tag, right? But in between it, I put a space after the p, and I added ID equals, and I put a string or a piece of text in there. I call it just me. What does that mean? Oh, sorry. Okay. On the beneath it, I have 3 more p tags, but rather than having something called an ID, I've now put space. I put class in it. So ID and class are what we call attributes. They're additional pieces of information or we call metadata. We can call it information for now, but just so you know, when you hear metadata, all it means is usually just attribute information. So ID and class are extra pieces of information that we add to tags because it's important to us because we're going to make use of that sometime. And so what's a common example of why we need metadata? Well, if I have 30 p elements on a page, but I only want to change the color of one of them to green, how do I go and say, hey, I want to pick out and do something just to that one element on the page? Well, in that case, an ID becomes the best way for us to do that. What ID, and by convention, what ID usually means is ID is a unique identifier. We'll talk more about identifiers tomorrow when we talk about CSS. But for now, just know that when we talk about ID, it pretty much just means, hey, only a single element on any given page should have this ID. Think of it as almost like a social security number, right? Like you wouldn't expect you and anyone else in this country to have the same social security number. So if someone says, could the person with the social security number, 1, 2, 3, 4, 5, 6, 7, 8 come to the front of the line, then you know by default that should only refer to one person. On the other hand, class becomes another identifier or another kind of attribute. But what it does is it actually allows us to kind of group different clusters of elements together, right? So on the ID side, if I said, so think of class as like dark hair, right? If I say, hey, could all the people with dark hair come to the front of the class? Well, that could be one person, sure, but it could also be like 3 or 10 or 100 people, right? There's no limit to it. And so attributes basically allow us for us to be able to very quickly identify either a single element or a group of multiple elements sharing a common characteristic. An element can easily so an element can definitely have both an ID and a class. But usually when someone says, hey, can you get me all the elements with this class or with this ID? That's kind of what they're getting at, is they're basically saying, hey, can I group these elements either individually or in a group? And can I use attributes like IDs and class to do so? You'll have more reading on ID and class in your workshop today, but this is just kind of a quick and dirty kind of primer on the difference between these two things. Are there any questions so far on really anything on any of the material that I've talked about? Yep. Yeah, you would just add an ID to only that element, and that will allow you to pick only that element. Yep. So I guess this is actually the last thing we'll talk about. It's a bit related to IDs and attributes. Is that whereas IDs and classes are kind of then become handy ways for us to group and pick individual elements. Some elements, like for example, if you look on the bottom there, the image tag, once again, right? The image tag, we talked about it earlier, because it's a self-closing tag. It actually also uses attributes to actually capture important information. In this case, whenever we're trying to show an image of anything on a web page, we have our image tag, and there's this attribute called SRC. And what the SRC attributes is actually tells us is, hey, I need to get an image, and that image is being stored at a certain location, and here is a location, right? Usually, it's if you're looking at a website, it's probably hosted on a cloud drive somewhere or on a hard server somewhere. Or if we're building sites locally, sometimes it's like it's stored in a place on your computer. In any case, just know that attributes are sometimes used not just for identifying, but they actually are valuable to the actual operations of the tag itself. So for image tags, the SRC attributes actually tells you where the image is being stored. And then there's another tag above, the A tag, right? Notice how it's the opening tag A and then closing A tag. What the A tag does is it's a link tag, right? It helps you create a link. So when someone clicks on it, it takes them to the link. And the A tag has something called an href. Has an href attribute, and the href attribute basically is just, hey, what link or what other website do you want to take this person to when they click on your page, right? So href for A tells you where to go on the link. SRC for image tells you where the image is being stored, and once again, all of these different images, all these different attributes. Some are used for classification, and some are actually used for the core operations of the tag itself. Do you have a question, Katie? Good. Okay. Yep. So some quick quirks and gotchas. One, and this I guess to address Trudy's question more directly, white space doesn't matter in HTML. And so if I could do something like this, or like this, or like this, oh, I went a little too fast. What we'll see is that actually all three of these are going to render the same exact way. What JavaScript, I keep saying JavaScript because it's the curriculum that I actually teach more often. What HTML actually does is when it sees multiple white spaces, is when it sees a white space, it recognizes it as a blank space. When it sees multiple white spaces in a row, it actually consolidates all of that into a single white space. And so that's why between the first and second example, even though we put a dozen spaces between hello and world, HTML sees that, takes out 12 spaces, combines into one white space, and says, great, there's your rendering. Similarly, if we put a new line in between anything, so here on the third example, we put hello world on a new line, that means nothing to HTML. It just says, okay, great, I'm going to render you the same way I've rendered everything else too. And so once again, this kind of brings back to the example that when you're creating a web page, it's so much more important for you to understand what the built-in design of the elements are. So how that how that element handles spacing, font size, color, etc., rather than trying to actually write it with white space, because the way that HTML is written does not translate to what gets rendered on the actual page itself. Similarly, if I put things across multiple lines, these two, same exact way. Why? Because they're both block elements, so they both are going to take up one line's width of space, no matter how I space out the HTML. And then the other kind of gotcha is that HTML sometimes is actually too forgiving. What does that mean? It basically means that a lot of times when you write code, if you write bad code in JavaScript, it just won't run. It'll tell you that there's an error. HTML, on the other hand, will always run. It will do its best to try to guess what you want. It will almost always be wrong. And so what's going to happen is you're going to get a website that doesn't look like what you thought it was, but you're not going to get an error message. And so what this just means is that whenever you write HTML, always actually run the code to make sure you know what it looks like. The fact that the code is running correctly has no bearing on whether or not the code is actually giving you the design in mind that you want. Okay. The very last thing we'll talk about as an aside, and we'll talk about this with all three topics of JavaScript, CSS, and HTML, is the idea of comments. Comments are basically messages that we write on the page that the computer more or less ignores. And in fact, when we write most comments nowadays in the editor, it'll actually change the comment text to a different color, so to make sure that people know it's a comment. Basically, it's just messages for other human beings who read your code. And once again, as you can imagine, comments not only do not get read by the computer, they do not get rendered by the computer as well. And so here on the left, and so in HTML, the way to write a comment is you have an open tag, starts with an exclamation point and 2 dashes, and then ends at some point with 2 dashes and a closed caret. And so here I have 2 elements, 2 p elements. In between, I have this very, very long comment. When I render it on the page, all that gets rendered is the first p tag and the second p tag. Usually people use comments to say, hey, like don't touch this, or hey, this is written this way, or whatever it is. Don't overthink it for now. Just know that there is a way to write code, to leave code reminders for other folks without having it count as real code. There's a question here. Can you run HTML through a coder that makes mistakes or address the comments? So there's different kinds of mistakes, right? Like if you have an open tag with no closing tag, that's a mistake a computer will catch. If your code doesn't spatially line up the way you want it to, but the code runs fine, that's still a mistake, but that's not one that any computer or editor is going to be able to catch for you. And so there are most editors do have kind of syntax software that helps you make sure that your spelling is correct, that you have closing tags, etc. But you should definitely not become overly reliant on them, because no editor is going to catch either logic mistakes or other types of mistakes that are not so straightforward with syntax. Okay, and so what are some of the common mistakes that people make? They don't close tags or quotes, for that matter. Quotes as in if you have an href, right? If you have an attribute and you want to give someone a website, well, that needs to be shown as a string with quotes around it. And if you don't put another quote in, it assumes HTML is going to assume that everything that comes after it is part of the text. Misspelling, way more common than you think. And then indenting properly is not once again, that won't change. We just talked about how whitespace doesn't matter. Whitespace won't impact, indenting won't impact how your code runs, but it will make it a big pain in the butt for someone else to read and understand your code quickly. And that's pretty much it for the material that I had today. Before we transition over to the workshop portion of the class, are there any questions on anything I've covered today? Once again, this is an introduction to HTML. In some ways we've barely scratched the surface of what HTML can do, but we at least want to make sure you're in a spot where you understand what HTML is, you understand the core basics of how it runs, and then we're going to have you obviously get your hands dirty and do a few exercises yourself. Any questions?